Welcome to Math 1324, Section 5.3. We add on to what we did in the last section. Now we find out that our feasible set, what is a feasible set? That's the solution. That's the set of points that solve our series of inequalities. If we have something that we like to maximize, then the maximize or minimize is going to occur at one of the corner points. So in this case, we have 5x plus 7y. We'd like to maximize it. The question could also ask us to minimize it. So let's just see. So plug in 0, 15. I get 105. If I plug in 0, 0 into the condition, I get 0. And if I plug in this last corner point, 15, 0, I get 75. And so now if you look at the three numbers that came out, one of them is the smallest. That's where the minimum is, and one of them is the largest, and that's where the maximum is located. And so that was the question they asked us. In question 2, we would like to maximize this particular condition, 5x plus 5y, subject to these conditions. So what we have to do to solve this problem is first figure out what all the lines look like. We know the last two means it's in quadrant 1. And we need to figure out which region works out of all that. Alright, so we take each of our lines and I found the x and y intercepts. So on this first line that's in red, it's 0, 30 and 15, 0. Okay. The second line, which is graphed in blue, x is 0, y is 12. Alright, that's there. And if y is 0, x is 24. Alright, I then picked a point to test. 1, 1 would work. So if I pick 1, 1, all of these conditions are true. And so the region that works is here in green. Now remember, to maximize or minimize, it will occur at one of these corner places. Well, three of the corners are again easy because I can see that we're at the origin there. We're at the origin there at 0, 0. This is 0, 12. This point we're going to have to solve for. I've already put in it's 12, 6. And this corner point is 15 and 0. So I took my two lines. I'm looking to see what do I want to eliminate. And I chose to eliminate the x's. So multiply this all the way through by minus 2 and add them up, and I get minus 3 y equals minus 18. So that says that y must be 6. And if y is 6, well then what is the x have to be? Well, if x is 6, 30 minus 6 is 24. 2x is 24, so I get x is 12. So this corner place is 12, 6. Armed with these four corner points, we now plug in each of the corner points into the thing we'd like to maximize or minimize. And so if I plug in 0, 0, I get 0, and so on. And so when I plugged in 12, 6, I got out 90. So looking at all these points, these things that came out, the largest number is 90, and that occurred at 12.6. And the smallest thing that came out was 0, and that was at 0, 0. All right, in question 3, we have something we'd like to maximize this condition relative to these conditions. All right, well, this last part here says we're in quadrant 1. This is a little easier because all we have is one line. So let's see, x is 0, y is 4, y is 0, x is 20. It's a solid line because of the inequality. And so now I want to pick a point to test, and so I can pick again 1, 1, and 1, 1 does work, and so the shaded region is everything inside of there. Since we don't have two lines, the corner points are easy. They're the x and y intercepts and the origin. So plug them in, and at 0, 0, I get 0. At 0, 4, I get 320. And at 20, 0, I get 200. So the maximum value is 320, and it's occurring at the point 0, 4. All right, and in question 4, we'd like to now minimize something subject to some conditions. So x and y greater than or equal to 0, that's the first quadrant. Okay, we have one line, so make x 0, y has got to be 10. If y is 0, solve for x and get x is 14. All right, so we have one line, and so now I can pick my test point again, easy test point, 1, 1. Test it out. So let's see. 5 plus 7 is 12, and is that greater than or equal to 70? No. So all the points in there don't work, so everything on the other side does. This is an unbounded region, and so since I'm adding things together, there's no way I could ever have a maximum. But we can have a minimum, and we only have two corner points to check. That is 0, 10, where I get 100. And if I plug in 14, 0, so I'm just plugging it into 9 times 14 plus 10 times 0, I get 126. We're looking for the minimum, so the minimum is 100, and that is occurring at the point 0, 10. And that's it. That concludes our linear inequalities and maximizing and minimizing